Hello friends, welcome back. Welcome to Kavita's classroom, and today's topic in hand is the average costs. In our previous video, we tried talking about the costs which are total in nature, right? Total cost, total fixed cost, and total variable cost. And we are trying to understand the producer's behavior so far. So when we talk about the totals, right? Total fixed cost is this, which is parallel to x-axis. Total variable cost begins from zero, means at zero level of production, it is zero in quantum, right? And it is inverse S in shape. So this is TVC. And when we add this constant value of TFC over and above this TVC, so it acquires exactly the same shape, and this is TC. And this is inverse S-shaped. Why? Because of law of variable proportions. So this is the crux of the story of our previous lecture. So let's begin now for averages. And it's from ages we are studying that average is nothing but the total divided by quantity. So now that we are talking about average cost, so it becomes total cost divided by the quantity. The formula somehow remains the same, but the perspective changes when we talk about average fixed cost. It means the total fixed cost divided by the quantity. When we talk about average variable cost, it becomes the total variable cost divided by the quantity. We are trying to get that cost in per unit form, right? So average costs, the formula is total cost divided by the quantity. In our previous video, we are continuing from that only. So our total cost was this. We added 10 each, the fixed cost to the variable cost, and we are simply dividing it. So at first level, when we are talking about zero level of output, it's infinite, because mathematics says zero in denominator is a danger sign. So it's just infinity. We cannot define it and express it clearly. Right. So here it is 20 by 1, 28 by 2, 34 by 3. So you get to have this. So when we try understanding how does this average cost look like, if we continue for some more data, right? So how would be the shape? It is going to be this AC. And why U-shaped? What is the significance of U-shape? U-shape says that initially the costs go down, and after a level they start moving up. Again, every U-shape in this chapter is governed by law of variable proportion. Law of variable proportion also says that the productivity initially increases, bit falls, and then starts falling down, right? So this is TP. So till it is increasing, whenever the productivity increases, it means the per unit costs keep going down. And when there is, a constraint in the productivity, the costs start moving up, right? So if we just try to check out, listen, one more thing. When we talk about average cost, as we know, total cost is equal to total fixed and variable, right? Sum total of these two. On a very similar note, AC would also be equal to total fixed cost. We'll say average fixed cost and average variable cost, or you can just divide these by quantity to get this expression. Right. So you have two formulas of finding AC. AC you can find by sum total of AFC and ABC, as well as by simple division of TC divided by quantity. Right. So to know about this, let's understand what is average fixed cost first. So how was our fixed cost? Fixed cost look like this. We must ideally keep 0th level of output also in the chapter of cost for a better clarity, because at 0th level also we have a fixed cost of the same quantum. Okay. Now, average is never ever defined at 0th level, so we will just mark it dash. So what's the formula? This is total fixed cost divided by quantity. And when we keep on dividing this constant value of 10 by bigger and bigger number at every next step, what do we get? We get this average fixed cost answer as falling at every step, right? So how does it look like? It gets to have hyperbola shape. This is rectangular hyperbola. Why? Because it's just going down, 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 and down. There is a question which is often asked in the paper. Would this AFC meet at some place when it is extended? No, it would never be so. Why it would never be so? Because if we try making it meet here, what does it mean? That at this level, the average fixed cost is zero, but AFC can never be zero. Total fixed cost can never be zero. So how could it be zero here? Right. So on extension also, it would never be meeting. It looks as if it's approaching x-axis, but it's never going to meet. And what's the significance of rectangular hyperbola? It says that all the points, the area under every point of rectangular hyperbola will give you the same value. You see, this is a common area of both, and this would be mathematically proved to be equal to this. So it simply says what's the significance of rectangular hyperbola is that area under the rectangular hyperbola at all the points would be the same. So how does AFC look like? It is this way, right? You just leave it here without touching it with x-axis, because that's the biggest mistake, the blunder on your part, right? Now, when we talk about average variable cost, formula is total divided by quantity, right? We have already jotted down the table of variable costs, right? And lately, I'll tell you how to have a trick of learning how should it be created, right? Means there is a trick. After we are done with marginal cost is U-shaped in nature. This is little premature, I'll tell you later. So once we are done with marginal cost, I'll give you a trick that you can create the whole table of good 7 types of costs in one go without any hiccup. Right. So average variable cost is, yeah, you keep on dividing this value with this value and you get to have the answer. Fine. Because we are now working on averages, the answers are expected to be in decimal points. You need not worry about the same. So average variable cost is U-shape in nature, right? And why? What is the significance of U? Whatever it is conveying is the significance that initially the cost falls and eventually the cost rises. Why is it so happening? Again, this U shape is governed by law of variable proportions. Now, when we talk about all the three in one particular frame, how does it look like? And this is the most important part of this chapter, most important, because students most often go haywire here only. So how does AFC look? AFC is rectangular hyperbola and it goes down, right? How does AVC look? AVC, you should just make like the tick, Nike sign, the tick of a teacher. This way you make AVC. Now, AVC and AFC, when sum up, give you AC. So, how does AC look like? AC is a U-shaped bowl in nature, right? See, how do we derive it? When AFC is going down, AVC is again going down. Of course, AC would be going down. But after this point, AVC has gone up, that too steeply, and AFC is still slowly going down. So what is going to be the net effect? Net effect would be the AC curve would go up, but not at this angle. Not at this slope. The slope would be little flatter, right? So this is AC. Try and understand. This is the sum total of AC is the sum total of AVC and AFC. So it gives you the composite effect of AFC and AVC. So it's just you create this way, a bowl in between this cavity, right? So when we talk about MC, we would be taking the lowest points and utilizing these two to make MC, but that will be done little later once we are done with that topic. So far we have done 6 types of costs. 3 are total and 3 are averages. Total fixed is parallel. Total variable is inverse S shape. and total cost again is inverse shaped, right? And when we talk about averages, AFC is rectangular hyperbola, AVC is U-shaped, and AC again is U-shaped, but AVC has got a steep slope, AC is with flatter slope a bit because its some effect is compensated by AFC, which is going down, right? So now, over for now, I'll say, and we'll continue with this topic later in the next video. Till then, see ya. I'm waiting for your responses and comments. Bye-bye.